Hello. So I am going to be starting to make more things online, create more content, as they say. And I have a lot of plans for this in the future to broaden the horizons of this education thing that I'm contributing to. But just to start off and get back into the swing of things, I'm going to do a recent paper for Pure One. It's a 2025 paper. And this is kind of the way I would recommend after you've taken my exam hack series and the exam gets closer, you should be doing timed controlled sort of exam conditions of like a test. You should do that. You should do that so you can prepare yourself for what it would be like in the actual exam. So I'm going to be going through a paper today, which I haven't really looked at. I haven't even looked at this content in ages. And I'm going to be going through, checking my answers, seeing how I do. And basically, you should be doing the same thing when your exam becomes closer and closer. So you can kind of identify where you're weak, where you struggle with, and how your time management is as a whole. And so we have this paper here, and I'll be going through it. It gives us an hour and 15 minutes. I'll probably do it quicker than that, but we'll see. And I'll go through and check my answers. If you're doing it, I would probably recommend you just do it and you check all your answers after you finish your exam in a kind of preparation. So you want to prepare yourself exactly how the exam will go, and that will help you so much. Anyway, I've got a bit of a new setup here. We have this. So I've got my formula sheet. I've got the answers here. So I'll go through, run through those answers, and I've got the formula sheet here so we can check if we're doing it right, basically. So go back to the Mac screen and let's just kick into it. How's everyone doing? How we going? How's life? How's existing? You know, it's a thing. Anyway, all right. It'll be also interesting to see how I do because I haven't done this stuff in ages. Okay. A curve has equation like this. Pretty cool equation, huh? And a straight line like this, where k is a constant. Find the set of values of k for which the curve does not, the curve and the line do not meet. I'm going to be going through and telling you my thought process of all of this. Immediately, I'm thinking about the discriminant. This thing here. When you have that factorization, when you're trying to find an x or you're trying to find x values. This thing here, under this square root, tells us how many intersections this has with in this case, will be the x-axis. And if it's just touching the x-axis, so it has one point of intersection, you could say, then this thing will just be 0. And but if it's less than 0, then it will give two intersections, and if it's greater than 0, well, because it'd be less than 0 will be above the x-axis. Sorry, it's been a while. Above the x-axis, because this is going to give what we call imaginary roots, which you would learn in Pure 3. But it will look something like, I don't know how much explanation I'm supposed to do with all this. I should be doing with all this. But if it's above the x-axis, this thing here, the discriminant, will be less than 0, because these intersections will actually be imaginary, but you don't have to worry about that. So anyway, so we have to find the discriminant when we equate these two things together and find for what values of k this thing is less than 0. So we equate them together. So we write out what they give us. I'm going to write it like this: minus 2x squared plus 3x plus 5, and we get y equals kx plus 13. Okay, we equate these things together, just like you'd equate it if it was y equals 0 and you wanted to find the x-axis intercepts. But anyway, so therefore, if you equate them together, you get minus 2x squared plus 3x plus 5 equals to kx plus 13, which gives us minus 2x squared plus 3x minus kx plus 5 minus 13 equals 0. 5 minus 13 is also known as minus 8. Crazy, huh? Now equals 0. I got my calculator handy because, you know, my arithmetic is, oh, it's great. Because I get distracted even while I'm doing stuff or start thinking about something else. Anyway. Okay, so now we have it in this form. So we should get it in the form of like a quadratic. So minus 2x squared plus, this would be 3 minus kx minus 8 equals 0. So this is our a, b, and c. So we find where b squared minus 4ac, this is going to equal, which is our discriminant. This thing is going to equal to b squared is 3. How many marks is this boy? It's 3 minus k squared and minus 4. A is minus 2 and b is, c is. So therefore we get, this discriminant will be 3 minus k squared. I'm going to use my calculator. Don't judge me, all right? I'm using my calculator for simple arithmetic. Just don't want to get it wrong. I would use it in an exam. So minus 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 will give a minus, so minus 64 equals 0. And so we actually want where this thing is less than 0. So we want where this thing is less than 0. But finding equal to 0 is fine, and you can solve that later. So we get, so we can times this thing out, we get what? 9. I'm gonna write it like this, it's easier for me. So this is gonna be k squared. Yeah, minus 3k and a minus 3k is just minus 6k, and then plus 9 minus 64 is less than 0. And then that will be k squared minus 6k plus 9. Sorry, it's been a while. Minus 55 is less than 0. Okay, so we can, what can we do here? So we can say, so we want to know where, so we get a k is equal to, so it'd be a k, what? Minus, what? So we say what times is into this that plus, no, what pluses into this, which times into this. That's how I remember it. You could use the quadratic formula, but you say, so minus, so this would be minus 1, 3, 4, 4. We're gonna have an 11 here for sure. Minus, it's just gonna be 11. So this is gonna be this, k minus 11 and k plus 5. And that gives us 5 minus 11 minus 6, and 5 times minus 11 is negative 50. So we want to know for what k values is this thing less than 0. So to do that, what you do is you equate it to 0. And you say, okay, you look at this thing, so this graph would look something like this. It's pretty good drawing. This graph would look something like this, where the intercepts are, so this would be, I'm just visually showing you what I'm doing. So y, this is y equals this thing, k squared minus 6k minus 55. This graph where these intercepts here are at minus 5 and 11. If you're unclear about anything I'm doing, I have an entire course going through all this material. I haven't even done this stuff in like a long time, and I'm able to still just pick it up so quickly. I mean, I'm pretty well versed in mathematics, but like I haven't done any of this stuff in ages. So, you know, the course works, and I made the course. So let's see, maybe I can get 100% of this paper. Okay, so So where is this thing? So where is this y less than 0? It's less than 0 between these two values. So y, this is our y and our x. So this thing here, which is the discriminant, is less than 0 between, so we can say this thing, so k plus 5, or this is the same thing, k plus 5 and k minus 11. This is less than 0 between when k is between these two values. So your answer is, so the discriminant is less than 0. The discriminant of equating these two, this line and this curve together, is less than 0, which means that the curve and the line do not meet for those values. So that means that the curve, so you can say the curve and the line don't. It's more mathematical to say do not meet for k values, for k so you can see the logic there. They do not meet if the discriminant of their equated equation, which comes from your understanding of the imaginary, the x-axis, and like how the parabola interacts with the x-axis, if it's one root or two roots or no roots. But when you equate them together, the discriminant is less than 0 when this line and this curve do not meet. And so therefore we found what k values would give a discriminant less than 0, and it's these, and that means that the curve and the line would not meet for this. Okay, so that's that done. Okay, so I'm gonna check these as I go through. So let's go back to my Mac screen. Okay, and let's see if I got this first one right. I'm not gonna cheat, so I'm just gonna go really slowly here so I can see. They've got all the descriptions as well. I haven't really read through this, what this means. But if we get the answer right. Okay, there you go. That's right. So we'll give it a tick. And so we've done everything basically the same as what they do here. So you set the discriminant less than 0. We've equated them together. We did the exact same thing. Except from they've just times through by a minus. Why did they do that? I just didn't times through by a minus. That's fine. It's the same thing. Okay, they just made it look easy. Okay, so that's the same. So we got all four there. Okay, cool. Let's move on. Okay, I've got to get used to this changing between scenes. Okay, back to my iPad. Alrighty, let's keep going. I might take a break halfway through, depending on how long it takes, because I think I'm going to be explaining everything in a lot of detail. Okay, so the diagram shows a curve with the equation like that. The curve crosses the x-axis at the point P. Oh, so this curve here is this. It crosses the x-axis at P is 1, 0, and a minimum point M. So just explaining what this diagram shows. So this is a minimum point. So find the gradient of the curve P, curve at P. Okay, so to do that, all we need to do is find the differential of this curve and then find what that differential is at the point 1, 0. Because the differential of a curve is just describing how the gradient of that curve is changing with respect to x. So if we take this line, let's just write it here, y equals 2x squared minus 5. I'm going to take that up like this, plus 3. So therefore, d, well, let's write it nicely. Don't give us any space. So dy by dx, so the derivative of this, is equal to d by dx of y, which is 2x squared minus 5x, negative 1 plus 3. So you take, because the derivative is, you can distribute it, so therefore dy by dx is going to equal to, Derivative of this is just going to be 4x. This is just you deriving as, I don't know what level everyone's at when they're watching this. So you times down by the power, down a power. So this would be plus 5x negative 2. And this thing, well, this thing is just 0. Derivative of constant, you have a straight line, the gradient never changes. Okay, so you get that. So therefore, we can say that dy by dx at this point, which is the gradient of the curve, at this point, where it's 1, 0, so where x equals 1, it's just going to be 4 of 1 plus 5 over 1 squared, which is also known as 9. So you can say, if you write it nicely, the gradient of at point P is equal to 9. Okay. Find the coordinates of M, give each coordinate correct to 3 significant figures. Okay, so, well, this is... Wait, the diagram shows the curve of the equation, this. Okay, so these are actually both, this is part of the same, they reach those kind of limits where they never touch, but then they, anyway. So this is all the same curve. So the minimum point, so we want to find this minimum point. So we have this, dy by dx equals to 4x plus 5 over x squared. So find the coordinates of M, give each coordinate correct. Okay, so the minimum point occurs, so a minimum, or you could say a stationary point occurs when dy by dx equals 0, because this gradient is 0 at M. Okay, so we equate this to 0, so we get 4x plus 5 over x squared equals 0. Okay, we times through by x squared, we get 4x cubed plus 5 equals 0, which gives us x cubed equals minus 5 over 4. So therefore x equals 2, you group that, 5 divided by 4, that's negative 1, so this is minus 1.25. You cube root that, we get, what, 3 significant figures. So this is minus 1.0772 ... But the 3 significant figures would be 1, 2, 3. So we see this figure, so this would equal minus 1.08 to 3 significant figures. And so therefore y equal, we just substitute this thing back into our equation. So y, they don't give us enough space. Ooh. You shouldn't plug the rounded value in, you plug this exact value in. So minus 1.0772, you get the idea. And I'm plugging it in into this. Minus 5 over minus 1.07, and plus 3. Okay, and if you plug all that stuff in, minus 5 over, should put it all in. Okay, so 2 times. So what I'm doing, I'm just putting the answer in to this calculator. Over answer, this answer. I'm not rounding it and plugging it in, just to be accurate. Make sure I get the right answer. Minus, oh, I forgot minus. Oh, it's this thing squared. No, this thing squared. What are you doing, bruh? Okay. 5. Like I said, I've never done this before. Okay. So I might make mistakes. But you can notice that I pick up if I made a mistake. Because, I don't know, something just fell off. Yeah, something fell off. Minus 5 over It's 3. Why am I getting something weird, dude? What is this? What is this? Maybe I should have done this beforehand. -5 divided by 4. Okay, this thing. 2 times answer squared -5. 5. Is my calculator being weird? I haven't used this calculator. -5. Gotta put brackets everywhere. -5. This plus 3. Point. I've done something. I feel like I've done something. 4. 5 divided by 4. I'm putting in the wrong value. I'm putting this in. What are you up to, Jake? Are you all right, man? Are you okay? Where is it? Okay, 2 times answer. Holy shit, dude. Squared minus. This is taking way longer than I thought it would. Maybe I'll be here for hours. Who knows? I need to concentrate. I haven't talked and done this. Okay, there we go. I was plugging, I don't know. It's been a while. Okay, just give me a break. I was plugging this in. So anyway, you get this thing equals to 9.962 dot 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 dot. But the 3 significant figures would be 9.96. So m is minus 1.08, comma 9.96. 3 significant figures. The only reason I knew I was getting that wrong was because, first of all, I didn't even put a square, and then I was plugging this in, so I was getting a completely random distance. Anyway, that's our answer. Okay. Right, I guess I should check that then. Okay, question 2. So go back to the max screen. Okay, let's go down here. Okay, the first one is 9. Cool. So this is how you should be doing it as well. If you want, you can check your answers as you go, or you can do your whole thing and then check them. Yeah, okay. 3. Okay, that's right. Okay. Okay, so cool. So I got all those right. Okay, then we go back to iPad, and then, and you shouldn't be looking at the mark scheme. So like, as you're going through, like you should do it like I just did it there, and not know what the answer is going to be, and then check. Only check once you finish the question. Don't look at the answer, like you're kind of cheating yourself there a little bit. Like I'm starting this again now. So you're seeing me go through this process of like learning how to do, well, relearning this content. Okay, so find the complete expansion of this. Okay, this is the binomial expansion. So I'm gonna have to go to my formula sheet here. So I'll go to my formula sheet and I'll find that expansion. Where is it? Where is it? Yeah, so the binomial series expansion. So find the complete expansion of this. So we'll be using this thing here. Okay, so I'll write it up here. So we have a plus b equals to an plus n1, an minus 1b plus n2. This is on your formula sheet, and you don't have to remember this. Plus, and then you just keep going. Keep going up and up and up. Okay, so this will be our a and our b, where our b will be minus, because this can be like written as 2x plus minus 3 over x And I might write that like this. Be times, no, actually it'll be fine. Yeah. So minus 3 over x. So it's our a, our b, and our n. Okay, so we just find the complete expansion. So we just basically just substitute into this formula. So this will be, so we'll have 2x minus 3 over x to the 4. This equals to an is 2x to the 4 plus, this is n1. So 4, this thing here is on, you can use this on your calculator. But this is 4 combination 1. So 4, I don't know if you can see this, but it's on your calculator. So this thing, yeah. 4 combination 1. So it's just 4. Maybe I'll sub that in later. But you put that in your calculator. You should know how to do that. 4. And then 4 times a of n minus 1 will be 2x to 3. And then b is minus 3 over x. And this thing to the 1. Plus, so you just basically iterate through this thing. So 4 combination 2 is 6. 2x squared minus 3 over x squared plus the next one is just going to be, well, you just keep going. So 4 combination 3. 4 combination 3 is 4 times 2x will be n minus 3, which would be 1, and then minus 3 over x 3, and then your last one would be 4 combination 4, which is 1, but I'll just double check that in my calculator. Pretty sure it's 1. 1, so nothing. 1 times 2x to the 0, which is 1 as well. I think it's about 0. And then you get minus 3x to the 4. Okay, so if you just simplify this, you get 2 to the power of 4 is 16x4 plus, here you get 2 to the power of 3 times negative 3 times 4. So you get, here you get a minus 96. I'm just simplifying these terms individually. And then an x cubed divided by an x is just going to be an x squared. Plus, here you get 2 squared times negative 3 squared, which is 9, so 36. So 2 times that times 6 is 216. And the squared will be positive, so this would be 216, and the x squared on the bottom will cancel the x squared on the top. So, and then the last ones will be 4 times 2 times negative 3 cubed. This is minus 216, and then this thing brought up would just be x to the negative 3. This thing is just, this is just minus 216 over x cubed, but I like to write it like this, which is, looks better. Minus, and then plus the last one, this to the 4, so it'd be minus 3 to the power of 4. This is 81x to the negative 4. Okay, so, I mean, you can rewrite it, I guess. No, I can't be bothered. Okay, so that's your answer. This thing here. That's the complete expansion. This is, you see, I'm making mistakes in a while. This is negative 2. I just double checked it, like after I just looked at it again. Like it didn't make sense, right? You had negative 3 and negative 4. Like x divided by x cubed is negative 2. No? You're going to get an x over an x cubed, which will give you 1 over x squared, which is x negative 2. See, I'm rusty. Oh, he's rusty. Hence determine the coefficient of x squared. Okay. So you got this times, well, we know what this thing expanded is. So the coefficient of x squared. So we want to look, so when we times this thing, to this thing. When we times these, because you're times in to each term, what terms are going to give us x squared? Well, let's just think about it. We have this entire thing. You can rewrite it out if you want. Maybe I should do that. Take my time. And I wouldn't be making mistakes. Plus 81 x negative 4. Okay, so what terms here in the expansion of this are giving x squared, coefficient x squared? Well, this one isn't, this one isn't, this one is, and this one is, this one isn't, this one is. So we have this one, so x squared, so we're just looking at these terms. So we have, so there'll be a bunch of stuff when you expand it out, but we're only interested in the x squared terms. This x squared times 216, so we'll just write it, x squared, we get x squared times 216. We also get, here, we get plus, we get, here we get an x squared times 81 over x4. That's also, that's not going to give an x squared. What do you want about, Jacob? Okay, so that's the only, so when we expand this thing in, that's the only thing that's going to give us an x squared term. I was thinking it's x negative 2. It will give you an x negative 2, but not an x squared. X positive 2. And then you look through here, so the only other thing would be this one. The rest of the stuff won't give you anything. So we also get plus 5 times minus 96 x squared from timesing this thing. And this one will give you an x squared, this one will give you this one, none of that. So these are the only two things in that expansion, which is quite a big expansion, which give you an x squared. So if we basically times, so we get 216 x squared, minus 5 times 96 is 480 x squared. So this is going to give us 1 plus 216 minus 264. So you're going to get a bunch of stuff, then you're minus 264 x squared, and a bunch more stuff. Okay, so the actual term is this term. So that would be your answer. Write it out more if you want. That would be your answer. Okay, and that's it for that one. Okay, let's check the answer. Screen. Okay, so the first one, 16 minus 96x squared plus 216. Okay, we got that. Yes, we got that, and then the other one was minus 264, and we got that. Okay, we got them both right. Ooh, okay, how do I get you back? Okay, iPad. Okay, so we got both of those right. I checked the answer. Okay, 4 marks. What are the 4 marks for? Oh, each one. Okay, apparently that's 4 marks. Pretty easy 4 marks. If you ask me. Okay, and that's 2. Okay, so we're at 100% so far. Just saying. Okay, let's keep going. Okay. The diagram shows a triangle OAB where OA and OB equal 10 centimeters. Okay, so they're just describing the stuff. Okay, point CD, blah, blah, blah. They're just describing this. So these are circles, CD such that part of a circle center 0, radius 6. The shaded region is bounded by the arc CD. And okay, cool. Find the perimeter of the shaded region. Okay, so straight away, I'm just going to write out what I need. So perimeter of the shaded region, let's call it P of S, is going to be, we've got 4, well, let's just write it out. We got AB plus CD, and then plus this 4 and 4, so plus 8. So we can find the perimeter of the shaded region if we find AB and CD. So what is AB and CD? Well, CD is just this is on your formula sheet. So arc length. So the arc length formula, so arc length which is, this is going to be r theta. So if we want this length CD, this is just on your formula sheet. It's for a circle. Then we basically, if we want, how should I do it? Length AB and length CD is going to equal to r theta, which is going to equal to r is 6 and theta is 0.8. So 6 times 0.8. Yeah, I'm using my calculator. Don't judge me. 4.8. So I mean, you don't have to plug it in yet, but you could say, I mean, you could keep r the same. So this is going to be the length AB plus 4.8. No, let's write it out. So r theta plus 8. Okay, and what is the length AB? The length AB could be figured out immediately, just saying you could create a right angle triangle here. So this would be half of that angle. So in fact, the length AB, well, you could say half the length AB, in fact, half the length AB over 2, this thing, because this is going to be halfway between, is going to be, well, we have opposite. This is just a right angle triangle, which you probably should have seen before. So this is our theta over 2 here. If we're treating theta as the same. Is that too complicated to do it like that? For me, that makes sense. This is just 0.4 radians, but I'm just keeping it in this form because I'm weird. So this is going to be half base. Our base is half base times height. So no, that's area. What am I on about? What am I talking about? See, I'm tripping, dude. Okay, so this is opposite. So this is our length AB. This is half our length AB. This is opposite, and we have this length of our hypotenuse here, which is just OB, and this thing is 10. So then we can say length AB. So we can say opposite over hypotenuse. So sine of theta over 2 equals to opposite, which is LAB over 10. Okay, so LAB equals to 10 sine theta over 2. Does that make sense? So I'm just finding this length here by creating a right angle triangle. I mean, maybe keeping it in exact form like this is kind of tricky. I mean, that's how I do it. So we can just, because I just want to write it all out. So this would be 10 sine theta over 2 plus r theta plus 8. Okay, we know what theta is, and we know what r is. So we find the actual perimeter. 10 times sine of theta, which is 0.8 over 2, which is 0.4, plus, well, we already found this, but 6 times 0.8, so it's plus 4.8, plus 8. So sine, so you've got to make sure your calculator's in radians. So sine of 0.4, isn't that really long number, times 10 plus 4.8 plus 8. So this gives us, oh, this is a over 2. Dude, I'm fine. This is not good. Whatever, we'll keep it raw. This is LAB, so this is over 2, so this is going to be 20. So LAB, see, this is why I shouldn't do it like this. Okay, that's 20. You get it? So this length here is LAB over 2. This length here is LAB divided by 2. It's halfway between that. So this thing is this, not LAB. There might be a formula for you to do the entire triangle like that, but a right angle triangle you can do like that. So it would be sine of 0.4 times 20. It's kind of a big difference. So this is 20 point, so rounded to be 20.6 centimeters. So Perimeter S is 20.6 centimeters. This is a tough first video. Find the area of the shaded region. Well, the area of the shaded region is just going to be this. So it's going to be, let's rub this stuff out. I might need it, but whatever. Is just going to be the area of this big triangle, this OAB, minus the area of this sector. So we could say the area of the shaded region is going to equal to the area of the triangle, call it AT, minus the area of the sector. Okay, so what is that? The area of the triangle is just going to be, well, I was already doing that before, so half base times height. So we have this thing again. So the area of this triangle, the area of this big triangle OAB is going to be half base. So area of the triangle is half base, which is AB, the length AB. We could just do each one. So we'll do one of these things first, because you can't do half base times height for the inch because it's not a right angle triangle. So it'd be half. So the area of this, of one of these things, so this area, let's just call it A. This area, one of this entire thing here. This entire thing here is just going to be half, keep it green, half base, which is this, the length AB over 2, which I already found before, which will be 10. This will be, so this is going to be 10 sine theta over 2, which is 0.4. So it'll be 2 times that. So we found half of this big triangle. So the area of this big triangle is going to be 2 times that, which should be 10 sine. Interesting. Is that right? Am I right there? Half base, got the height. Half base, dude, I'm all over the shop. Half base times height. Our height is, oh, we have to find our height. Oh my god, this is so annoying. Okay, so the area 1, this triangle, is half base, which is, so half base times height. So we can use this thing, which we found before, to be this thing here is, we could say it's a height. So it's 10 sine 0.4 times a height, which is, we can use this one here, which will just be what? So this one will be opposite. So opposite adjacent. So cos of 0.4 equals to, so I'm finding this length here. This is so badly explained, I'm sorry. Is adjacent, which is the length that we want. So this is our height over 10. So 10, so this would be times half times 10 cos of 0.4. Okay, so this thing will be what? 10 is 100, so 50 sine 0.4 cos 0.4. So this gives us half of that big area. This is so bad, I'm sorry. Do you like it like this, just, or do you want me to like really prepare the video? So this is the area here, A1. So 2 times this, so this thing is like 17.933 dot dot dot. And then 2 times, so the area of the triangle will be 2 times this. So 35.8 6, 7. Okay, so this would be 35.86 rounded 8678 minus the area of the sector is, again, you have that on your formula sheet, is half r squared theta. So an area of a sector is half r squared theta, where r in this case is 6 and theta is 0. So 6 squared 0.8 minus 0.5. 6 squared times 0.8. So I got 21.46. This is 21.467. So round to be 21.4 centimeters squared. That was really poorly explained. I'm sorry about that. We were just trying to find the area of this big triangle OAB, and by doing that, all I did is I found the area of this smaller right angle triangle here and multiplied it by 2 to give us the area of the big triangle, because it's half of that area, the big area. And to do that, I needed to find this value, which we already had, this length here, which we already had, and I also needed this length here, which I found by using another right angle triangle. If that wasn't explained correctly, sorry, you can ask me again. Well, I might not have even got it right. Let's have a look. Screen. Okay. What is this question for? 20.6. Boom. Tick. 3. And 21.5. Boom. Okay, we got that right, even though it was poorly explained. Okay, let's go to iPad. Okay. Oh, not one of these again. 6 marker. Maybe I'll take a break. How long is this thing? 6, 7, 8, 9, 10. Maybe I'll just bang it out. I'll just go faster. Okay. Arithmetic. Okay, so arithmetic is this thing. Arithmetic series. So UN equals A plus N minus 1. I have videos on all of this stuff. And the sum of N is half N 2A plus N minus 1D. That's on your formula sheet. So an arithmetic progression has the first term 5 and a common difference 6. So first term 5. Okay, so our A is 5 and our common difference here is 6. Okay, for this progression, find the sum of all the terms that lie between 150 and 400. Okay, so to do that, so we're looking for the sum of all the terms. So we need to find what first term, what n in this progression lies above 150, is in above 150, and the last one that lies below 400. So we need to find what those are first. So 150. So A plus n minus 1 D equals 150. So what is what n value do we get? It'll probably be a decimal. Do we get to give 150? So we start to be in this sort of range of 150 to 400. So, and then we're trying to find the sum of all of these all of these, like what do they call it? Like points in the terms in the series. Okay, so we need to find what the first term that's in that range is and the last term in that range is. Okay, so A is 5 plus n minus 1 we don't know. So n minus 1, 6 equals 150. So we take the 5 over, we get 145, 45, and then divide by 6, and then plus 1. So our n is going to equal to that. So our n equals to 145 divided by 6 plus 1. This is 25.1666. Okay. So that means that the first term in the series, so like if you plug in 25 in here, so you do 5 plus 25 minus 1 will be 24. 24 times 6, you get 149. So that means that so for n, because they're discrete values, right? So for n is 26, this is a term where un is greater than 150. Does that make sense? So when n is 26, so 25 is when it equals 150. So that means when at 24, because it's going up, so 25 is going to, 25.166 is when it equals 150, like we found here. And then so 24 will be below 150, and so 26 will be above. So this is where we start to enter into this range. And basically we do the same thing here. So a plus n minus 1 d or equals 400. So we do the same thing. This is 5, this is 6. So we divide 400 by 5. No, 400 minus 5 is 395 divided by 6. Gets rid of that, and then plus 1. So the same thing. This gives us n equals this. So n equals 2. We put that in. 395 divided by 6 plus 1. 66.833 dot 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 dot. So then that means that so n will be, so when it's less than, so this is when it equals, so this value of n is when it equals 400. So when un equals 400, this is our value of n. So for n equals 66 is when un is less than 400. Right? So the value of n equals 66 is less than 400. When it gets to 67, it will be over 400 and will be out of that range. So therefore, if we want to find the sum of all the terms that lie between that, we want to find, well, the sum, we have like, this is our 150 up to our, this is our u, where we get to like, so this would be like u25, and then u26 is now within this range. And then we have all these terms, and then we have a u66, and then we have 400. Then we have more terms. This would be u67, yeah. And so we want to sum up all these things, all these terms from u. We want u26 sum up to u66. So if we do the sum, this formula here, if we do the sum of 66 up to 66, will be all of those minus the sum up to 25, not 26, because 26 would include 26, and then it would minus one more term out of the terms that we need to sum. So it would be s is 25, and this, the sum of all those terms minus the sum of all those terms, will give us the sum of all of these terms in the middle. So this is the total sum. We could say, I don't know, s total, what we need. Our answer. So what is this? This is just sum, we just plug it into here. So this would be a half of n, which is in 66, half, so 66 over 2 times 2a, which is 2 times 5, so it's 10, minus plus n minus 1, plus n minus 1 is 66 minus 1 will be 65 times d here, which is 6. Okay, that minus now 25 over 2 of 10 plus 25 minus 1, so n minus 1, so 24 times 6. So therefore, this total equals 66 divided by 2 is 33 times 10, so 65 times 6 plus 10 times 33. So you get 13,200 minus, the next one is 24 times 6 plus 10 times 12.5. 1925. Gives us 11,275. So that's our answer. 6 marks. I think the hard part there is just kind of the approach, possibly. Wait, I should probably check it out. Okay, max screen. Okay, this is question 5. 11275. Okay, cool. I got it. Okay. Cool. Okay, let's just move on. I feel like this is already running quite long. Okay. The diagram shows a circle C of radius R, blah, 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 blah. The least distance between the points on C and the x-axis is 8 units. Okay. So the least distance, this is 8 distance. Okay, and the least distance between any point on C and the y-axis is 5. Okay, so the least distance here is 5. Okay. Okay. Say the coordinates of the center of the circle R. Okay. Well, this will just be what is it? So 8. So this will be this least point here. So this will just be R in terms of R. So the center will just be our x will be R plus 8 and R plus 5, right? This is our least distance here and least distance here. This is just going to be R plus 8 and R plus 5. Wait, no. Say the coordinates of the center, so the distance between any point and the y-axis 5 units. So this will be R plus 5, because this is the x point here. R plus 5, and this is R plus 8, the x and y point. Yep. Okay, given that the distance between the origin and the center of the circle is 15 units, find the value of R. Okay, given the distance between the origin 0, 0, and the center of the circle is 15 units, find the value of R. Is this just gonna be like, well, okay, we have this distance here and this distance here. We just use a right angle triangle and then equate it to R. Can we do that? Let's see. So this length here, so call this, so this right angle triangle. So this is 15. This length is 15, right? The distance between the origin and the center circle is 15. Okay, so this is 15. This length here is gonna be, well, this is our y value, so it'll be R plus 5. No, R plus 8. And then this distance here will be R plus 5. Okay, so, you know, from Pythagoras' theorem, we could just say that R plus 5 squared plus R plus 8 squared equals 15 squared. Right? This is just that Pythagoras' theorem. A, B, C. A squared plus B squared equals C squared. And then if we solve this, we can find R, right? Yeah, so therefore we get, so this is just going to be R squared plus 10R plus 25 plus R squared plus 16R plus 64 equals What's that? 225. 15 squared is 225. 225. So therefore we get 2r squared plus 10, so 26r. 25 plus 64 is 89. So 89. So we take that over, so we minus 225 from 89. Yeah. Minus 136 equals 0. Divide by 2 to make it look easier. Plus 13r minus divided by 2 is 68. Is this some like easy thing? 4. I don't have to use 4 minus 4 plus what? Plus 4 plus 13. 4 minus 4. So minus 4 times 17. Yeah, it is. So therefore we can say r minus 4 and r plus 17. Music stops. Chill me out. No, we don't want Kanye West. It's not a good idea for studying. I mean, depends what you're doing. I mean, this has already been an hour. Jeez Louise. Okay, anyway. Which is correct, right? Times that plus that gives that. Okay. So r equals minus 7, minus r equals 4, and r equals minus 17. But it can't be this because r has to be greater than 0. See on here. Right? It can't be negative. You can't have a negative radius for a circle. I mean, unless it like imploded, like broke space-time or something. Anyway, okay, so r equals 4 units or whatever. Okay, that's your answer. Okay, it's been an hour then. So I need to speed up a bit. I don't know. I guess is it fine just relaxing with me? I haven't done this stuff in ages, but as soon as I start doing more videos, I'm gonna pick this up like it's really quickly, I think. I mean, I'm already on 100%. The point on the circle furthest from the origin is denoted P. Find the gradient of the tangent to the circle at P. The point on the circle, hold on, just make sure. The point on the circle furthest from the origin. So that'll just be here. So that'll be 15 plus 2r distance away from the origin, right? 15 plus r. I don't know if that's relevant or not yet. Just noting that. Find the point on the circle. The point on the circle furthest from the origin is P. Find the gradient of the tangent to the circle at P. Well, okay. Well, we have this line. We have this line to P here. This line, and it has what? It has just. We can just find its gradient. Isn't this gradient just... We have a point on the line. We have the distance here. We have this distance here. So we have this. So what is this line, basically? If we find this line, then we can find the tangent here. Because it'll just be the negative reciprocal. So y equals mx plus c. We have 2 points. So what's the point? Point is what? What is the point? Hold up. The point on the circle furthest to the origin denoted by P. Find the gradient of the tangent. Shit. Find the gradient of the tangent to the circle at P. So we just need the gradient of that line, right? Do we? I need to fix my thing. The gradient of the line. We have R. Okay, no, this is easy. Yeah, okay, this is easy. Okay, so we just, all we do is this. Okay, so we need, basically we need the gradient of this line here. And we can find the gradient of this line. The gradient of this line is just going to be, because if we find the gradient of the line, then we can find the gradient of the line that passes through P. And then if we find that, then we can find the corresponding tangent line, which will just be the negative reciprocal of this gradient. So this is just going to be rise over run. So our rise is r plus 8 and our run is r plus 5. So r plus 8 divided by r plus 5, which is 4 plus 8, which is 12 over 5, which is 9. So this is 4 over 3. So therefore the gradient of our tangent would be the negative reciprocal. So it should be minus. Right, we found the gradient of this line here, which passes through P, and then so therefore we can find this. So the gradient is M, and this will be minus 1 over. Okay, and that's done. Okay, let's check those. Okay, next one. Okay, R plus 5. Okay, that's right. Boom. This one is equal to 4 units. Boom. And this one is minus 3 over 4. Boom. Okay. Okay. I'll be back. My bad. Okay. Okay, there's like, well, a few more. Let's go. Okay. Show that this equals this. Okay, so this is just an identity question. Okay, so 3 tan squared theta plus 5 sine squared theta equals this. Okay, so we got to go to our Mac here. Okay, we just got to quickly look at our what identities they give us. Do we actually need any of them? Possibly not. Maybe. Okay, so this thing will just be equal to, we'll use this identity. Oh, I need to switch back to my Mac screen. Okay, iPad. So this identity, so it's tan theta equals sine theta over cos theta. This will equal to sine squared theta over cos squared theta plus 5 sine squared theta. The reason I'm doing that is because I can see everything's in sine, so I'm just progressively getting everything into sines. And we know that we know that sine squared theta plus cos squared theta equals 1. So therefore cos squared theta, so this will be sine squared theta over 1 minus, if you take that over, so 1 minus sine squared theta plus 5 sine squared theta. We can already see it's got this. Okay, so now let's just merge this into one fraction because we have one fraction up here. So this would be 3 sine squared theta over 1 minus sine squared theta plus 5 sine squared theta times 1 minus sine squared theta over 1 minus sine squared theta. So just getting a common denominator. And then we get 3 sine squared theta plus 5 sine squared theta minus 5 sine 4 theta all over 1 minus sine squared theta. And that's looking good. So therefore we get this, and this will be 8 sine squared theta minus 5 sine 4 theta divided by 1 minus sine squared theta. Okay. 8 sine squared theta minus, yeah, boom, there, we got it. Well, I know that's right before even checking the answers because I proved it. Okay, hence solve this. Can do, can do. Okay, so we know that this thing is the same as saying, because of the identity we just proved, is the same as saying 8 sine squared theta minus 5 sine 4 theta, 5 sine 4 theta divided by 1 minus sine squared theta, 1 minus sine squared theta equals 9. Because that is the same as the thing we proved above. Okay, we want to solve this. And why do I change it into that? Because here we have it all in terms of sine squared theta, which is a lot easier to deal with than a tan and a sine. Okay, and we want to solve this. So let's times through, like, let's simplify this. Sine squared theta minus 5 sine 4 theta equals 9, 1 minus sine squared theta. Okay, this gives us 9 minus 9 sine squared theta. So let's take everything over here. So therefore we get 5 sine squared theta. I've just taken, sorry, I'm just taking this stuff over. This minus this is going to give us minus what? 9 minus 8. I can't believe I just put that in my code. Minus 9 minus 8. Are you alright, Jacob? Sine squared theta plus 9 equals 0. And we can solve that by saying, making x equal to, right, this is all right, 8. So take that over, minus 17, 5, give a 9. Yes, that's all good. Okay, x equals sine theta squared theta. We make x equal to sine squared theta, we get this thing becomes 5x squared minus 17x plus 9 equals 0. And this is something we can deal with, for sure we can deal with this. So, okay, so then we want x equals, I'm just trying to put the music back on. X equals minus 17 will be, so this is just the quadratic formula, minus b, so it'd be 17 plus or minus the square root of b squared, which would be minus 17 squared, minus 4, 5, 9 over 2, 5. So minus 17 times minus 17, that minus 4 times 5 times 9, 109. So this is 17 plus or minus the square root of 109 over 10. Okay. So okay, so what do we need to do here? Okay, so therefore we have our x values equal to, so then we can find our sine. So we have our x value, we have 17, so we can plug this stuff in. So we have our x value equals to 17, plug this stuff in, 17 plus the square root of 109 divided by 10. So this gives us 2.744 comma, and x also equals 17 minus the square root 109 divided by 10, which is 0.6559 . Okay, so we have these values, but remember x is sine squared. So x is sine squared. I'm getting fatigued. We should take a break. Or should we just bang it out? Should we just do it? Let's just do it. We can finish it. Come on, Jacob. Okay, so therefore we get, so sine squared theta equals this and this. So when we square both of these, we square this thing. Remember, it's going to be plus or minus. And square this, plus or minus 0.6559. We're going to get sine theta equals to... We're going to get a lot of stuff here. So 17 plus the square root of 109 divided by 10. If we square root this, we get plus or minus the square, plus or minus 1.6565, and then here we get sine theta equals to 17 minus the square root of 109 divided by 10. Then square root that. Get 0. Plus or minus 0.899 dot dot dot. Okay, so we have, now we can find our thetas. Remember, the sine graph looks like this. So, you know, this plus 0. We want thetas between these. So this plus 1 will give us, so this one here, so we get a theta equals to, from here, we do shift sine answer. No, okay, that's because it's in radians. I need to put it back in degrees. I was like, what? It's so small. Okay, degrees. So should have kept this in exact form. I think it would be fine. I'll just round it. It should be alright. So 0.8099, and then we go shift sine. So 54.1. So if you take this, so if you take theta equals the inverse of sine of 0.899, you get 54.1 degrees. I just rounded it. Okay. And then, you know, from this sine graph, you can figure out the other one, because the other one will just be the negative. We're not actually interested. So this value here is this, and then we're also going to get, let's draw it down here. So we got this sine graph, and 270 will be 180. So 270 is here. This is our 54.1. So the next one, so this is 180. So the next one is going to be here. So this one here will be 180 minus 54.1. So this is 125.9 degrees. And the negatives are just giving this stuff here. So we don't need to worry about that, because it's outside of the 0 to 270. The negative one would give this one here, I believe. So what would be 270, 180, wait, so 180 plus 54.1? 234.1. So this negative one, I guess this is impossible, right? So this one is actually impossible, because it's greater, this is bigger than 1. So if you take sine inverse of 1.65, yeah, you can't do this. This is impossible. So this is not possible. So you'd write that in your exam, not possible. But this one is. And then the negative, so the negative one would just give minus 54. If you take sine inverse of negative 0.8099, you'll get negative 54.1, which is this thing here. So that means that you can also get this result here, which is 180 plus 54.1. So this is 180 plus 54.1. Just also give 234.1. And then everything else is going to be greater than 270. So these are the only results that we really care about. So that's the answer. Yes. You only get 3 results, right? Yeah. All right, let's just check that. Max screen. Oh, here. 54.1. Okay, correct. Cool. Yeah, they did the same thing as I did. Cool. Okay, let's keep going. I'm gonna push through this. Let's go. Okay, 8, 9, 10, 11. Okay, come on, Jacob. You can do it. You can do it. A geometric progression. Okay, so we got to look at our geometric progression formulas. Where are they at? Geometric progression formulas. Okay, we got these two formulas. UN equals to ARN minus 1 and SN equals to A of 1 minus Rn over 1 minus R, and S sum to infinity is A over 1 minus A over 1 minus R. Okay, find the a geometric progression is such that the second term is negative 120 and the sum to infinity is 160. Find the common ratio. Well, the common ratio is just gonna be, so like let's say you have U2 equals, will be A R 2 minus 1 is AR. So okay, yeah, you can do this for sure. Okay, so 160, so negative 120. So negative 120 equals AR. Okay, so that's one equation. And another equation is the sum to infinity equals to A over 1 minus R. So that means that the sum to infinity of 160 equals A over 1 minus R. So therefore we get A equals to 160 minus 160. I'll just keep it like that. Equals to 160 1 minus R. We could call that equation 2. So we have two equations here with two unknowns, so then we can find both of those unknowns. So let's plug in, what would be the easiest? Let's plug in, so therefore, so this one we could say R equals to minus 120 over A. So if we plug in equation 1 into equation 2, we get A equals to 160, because if we find A, then we find R. R is the common ratio. So 1 minus 120 over A. And this thing equals to 160 of 1 times 1 plus 120 over A. So we times that stuff in. This gives us 160 plus 120 plus 160 is 280 over A. Times 3 by A. Yeah, A squared equals 160A plus 280. Why don't they give us any space, dude? It's just like so shameless. Where's my space? Did I just say shameless? It's so shameless, man. A equals this, right? A equals I equals minus 120. Yes. Sum to infinity equals A is. Okay, so what? So we have to just find out. So we get A squared minus 160 minus A minus 280, 0. So what? A equals what? Oh, I might need to take a break here. I'm so tired. That's not 280. What am I on about? Yeah, I just gotta push through. 160. I'm so tired. 160 times 120. I did plus, not times. See? I'm all over the shop. 9, 2000. A. Over A. A squared 9, 2000. So what is that? Oh, I can't be bothered thinking about it. I'm just gonna A equals minus B. So we can rewrite this. A squared minus 160A minus 9620. This is a minus, right? Minus, 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 minus. Okay, so what is that? 200. Okay, so I'm gonna take a little bit of a break after this question because I'm getting tired. Or should we just push through into it? Let's push through into it. So minus B. So 16 and into 920, 19. So minus B, so 160 plus or minus the square root of B. So it's gonna be huge. Wow. Minus 4AC times 9,200. Minus B squared minus 160 squared minus 4 times negative 200. Square root answer 320. Okay, I just did it through that. 16 plus 160. 160 divided by 2A. So it's 240. So A minus 240. And the other one will be minus 240. So what is, oh my god, I can't be bothered. A minus B, so minus 160. 160. The square root of plus or minus. What, 240? 240. 240 times what gives us that? Times 80? 240 times 80. Okay, so this is minus 80. Plus 80. God. Okay, so A equals this. They give me no fucking space. A equals this. So A equals either one of these. Can A be negative? I don't know yet. So then our R equals to minus 120 equals A R. So R equals to minus 120 over A. So either one of these. So A equals to the minus 120 divided by 240. So it's either R equals minus a half or R equals to what? Minus 120 divided by 80 is minus 1.5. No, so positive 1.5. Is there some sort of restriction on your formula sheet? Yes, there is. Okay, where are you at? Okay, so your R here has to be less, the absolute value of R has to be less than 1, so this is not possible. So your answer is R equals negative R. Okay, the first 9 terms of the progression are now removed. Okay, right. First 9 terms of the progression are now removed. The sum to infinity of the remaining terms. Find the sum to infinity of the remaining terms of the progression. Okay, can do. Okay, the first 9 terms are now removed. 9 terms of the progression are now removed. Okay. Find the sum to infinity of the ring. Okay, so what is the sum of the first 9 terms? Let's just find, you just want to find the first, you just want to find the 9th term, right? The first 9 terms, so you want to find the 10th term, so you want to find U10. Because we've got all those U0, U1, U2, U3, all the way. The first, like up to 9, they're all being removed, so they're gone. So this is going to be our new A. So our new A. So A new. So what is this? Well, we have our R, so this is just going to be our A old. So this is equal to our A old times what? R n minus 1. So R n minus 1. So in this case, it's going to be A old, which we had to be 240. So it's 240 times R, which is minus a half, to the power of 9. So this is our new, so minus 1/2 to the power of 9. So this is our new, what? So this is our new minus 15 over 32. So our new A. That doesn't really make any sense, does it? Does it? Let's just see where this goes. Okay, so find the sum to the infinity. So the sum to infinity now is just going to be, this is our new A. So it'd be minus 15 over 32 divided by 1 minus, R is the same, so 1 minus a half. So this thing divided by 1.5. So it gives us minus 0.3125. So the sum to infinity equals minus 0.3125. Getting a bit over this, to be honest, boys and girls. All right, let's go and check these. Where we at? Max screen. Okay, so we got R equal, where are we? R equals negative a half only. Okay, boom, got that right. Okay, 4 marks. Jeez Louise. Okay, and sum to infinity is negative 0.3125. Negative 0.1325. There you go. Boom. Boom, boom, boom. Okay, come on, Jacob. Push through. I can push through. I can do this. It literally wasn't even recording my iPad screen for doing this last couple questions. So it's the last question. Okay, anyway, let's just do this. Okay, a curve is such. Okay, you got this curve, second differential curve. It is given a stationary point here. Use the expression to determine the stationary point's maximum, minimum. Stay here, buddy. Okay, so if you remember that this thing, if this thing is greater than 0, then the curve is minimum, and if it's less than 0, it's maximum. Okay, so we just basically substitute in that point. D squared y by dx squared equals, we substitute in the point, the stationary point, so where x equals a half. This is going to be
6 over a half to the 4 minus 5 over, which equals 1/2 to the power of 4, 6 divided by answer. This is 96 minus 1 over 3. Video is way longer than I thought it was going to be. Minus 40, that minus that is 56. So this thing is greater than 0, so therefore stationary point is minimum. Is minimum. Okay, so it's a minimum. Okay, find the equation of curve. Okay, so all we really have to do here is just integrate twice. And so you integrate, you want to, so you have this dy, d squared y over dx squared. You integrate this, which is basically the equivalent of doing this. It's this, we have the integral 6. I'm just taking these things up, making it easier. Okay, we integrate that. This is just the primary rule of differential calculus and integral calculus. This just goes away. You get dy by dx equals to, you get 6x to the negative 3 over negative 3 minus 5x to the negative 2 over negative 2 plus a constant, which we don't know. Okay, we simplify this. This thing is going to be what? Minus 2 minus 2x to the negative 3. This will just be plus. Okay, so I'll just simplify that. Okay, to find this C1, we have it as a stationary point. So when x equals a half, dy by dx equals 0. Okay, so we can substitute to find C1, we can substitute in the point half, 0. 0 equals to minus 2 of a half to the negative 3 plus 5 over 2 of a half to the negative 2 plus C1. And this will help us find C1. So half 3 times negative 2. So this equals minus 16 plus negative a half to the power of negative 2. This gives us 4 plus C2. C1, sorry. Okay, so we get minus 16. No, we got negative a half. Should probably write this. Negative a half. Yeah, negative a half to the power of negative 2. 4, so then 5 over 2 divided by 4. What have I done here? Five times 4 divided by 2 is 10. A half the power of negative 2 is 4 times 5 over 2. 10. I don't know what happened there. So therefore C2 equals what? This would be minus 6. So take that. C1, sorry, equals to 6. Okay, so therefore we get dy by dx equals to minus 2x negative 3 plus 5 2x negative 2 plus 6. Okay, so then we integrate one more time. We get y equals to minus 2x negative 2 over negative 2 plus 5 over 2x negative 1 over negative 1 plus 6 plus another constant C2. And we can simplify this. We get x negative 2 plus minus 5 over 2x negative 1 plus 6 plus C2. Oh, when we integrate that, it was 6x, so this goes upward. Okay, so sorry, I'm fatiguing. I've been doing this like now for 2 hours. I'm just sitting here.
Yeah, whatever. Okay, so define C2, we can just sub in this point that we have, a half and 9, which exists on the curve. So define C2, we sub in the point a half 9. So therefore we get 9 equals to a half negative 2 minus 5 over 2 half negative 1 plus 6 half plus C2. Okay, so what is this? Scrap 1 half to the power of negative 2. 4 minus 2 times 5 divided by 2. This is 5 plus 3 plus C2. This is 9. So we go 4 minus 5 plus 3. So therefore C2 equals 7. So therefore our final curve is, if you write it nicely, it will be minus 5 over 2. I guess you could write it 5 over 2x plus 6x plus 7. So that's the equation of your final curve. Let's go to the Mac screen and check this. Okay, so we got minimum, which is correct, and the final curve is correct. So it's the same thing. Okay, so both of those things correct. I have to remember to go back to my iPad and do that before. So this is correct. This is correct. Okay, 2 more questions. Okay, the diagram shows the curve this, the region of x for 0. Okay, appears. Okay, so just explaining this curve. This is at 7. Does it say where Q's at? Region A is bounded by the curve, and the 2 axes. Region B is bounded by the curve. Okay, find the area of A. Okay, we just integrate it. That's pretty easy. So the area, so A area is just going to be the integral of 3x plus 4 to the half minus 2x minus 6 dx. It's going to be this between 7 and 0. What is this? Well, this thing is going to be 4 of 3x plus 4, go up by a power, divide by the power, and due to the chain rule, divide by this thing differentiated, which is 3, minus 2x squared over 2 minus 6x between 7 and 0. This thing will be 3x plus 4, 3 over 2, which is 9 over 2 on the bottom. So 4 divided by that is 8 over 9. So this thing simplified becomes 8 over 9, 3x plus 4, 3 over 2, minus x squared minus 6x between 7 and 0. Okay, so then we just substitute the stuff in. So the area is going to equal to, well, first with 7, we get 3. Well, I'll write it out for you. So 3, 7 plus 4, 3 over 2 minus 7 squared minus 6, 7 minus this thing will be 8 over 9, 0. So this would be 4, 3 over 2, it'll be 0 minus 0 squared minus 0. This will be 0. Okay, so then we get what? 3 times 7 plus 4 to the power of 3 over 2 times 8 divided by 9. Okay, so this is 1000 over 9 minus 49. It's 42. So 7 squared, yeah. 697, yeah. Okay, so that thing minus 4 to the power of 3 over 2 times 8 divided by 9 is what? 64 over 9.
Okay, so 1,000 over 9 minus 49 minus 42 gives us 181 over 9 minus 64 over 9. So minus 64 over 9 gives us 13, which is a promising number. 13 units squared. I should make it red. I'm going a bit fast now because I'm fatigued. Okay, next B. Find the area of B. Find the area of B. The area of B is just going to be the area of this triangle, this entire triangle minus the area of A. So we can say the area of B, let's just call it B area. I like it like this. Area of B is going to be the area of the triangle minus the area of A, which we had there, so minus 13. Okay, so what is the area of that triangle? The area of that triangle, the area of this triangle is going to be half base, which is 7, times height, which is this OQ length. In the OQ length is, what is it? The OQ length. We have the gradient of this line. Right? How many marks is this? 5. Okay, so I'm gonna have to do some weird stuff. If we find the gradient of this line, we can find this y-intercept. So we can find the gradient of the line, then we have a point on the line, and then we can find its y-intercept. So first we need to find equation of line QP. Okay, so the equation of the line QP. So we have y equals to 4 times 3x plus 4 to the half, or minus 2x minus 6, minus 2x minus 6. Okay, so then we're going to find the equation of the line. We're finding the equation of this line so we can find the Q point, and then if we find the Q point, we can find the distance OQ, and then if we find the distance OQ, we can find the area of the triangle, and then minus it from the area A, and then get the area B. Okay, so this is going to equal to 4 times down by the power, 4, go down a powers minus a half, times by this differentiated will give us times by 3 as well. And then this thing is just minus 2, and this thing will be 0. Okay, so this thing is what? 4 over 2 is 2. Times 3 is 6. 3x plus 4 to negative a half minus 2. Okay, so if we want the gradient of that line, so the gradient of the line is going to be dy by dx at the point P, and the point P is x equals 7. So we get x equals 7. We get 6 of 3 times 7 plus 4 to the negative a half minus 2. So we get the gradient. So we get 3 times 7 plus 4 to the power of negative 1 over 2 times 6 minus 2. This is minus, the gradient is minus 0.8. So therefore we have the gradient of this line, and we have a point on this line, which is the point 7, 0, which is that point. Okay, and so therefore we get y equals mx plus c. So we get y equals to minus 0.8 x plus c. So then we can find c by substituting in this point. We get 0 equals minus 0.8 x. This will give us this point, right? Yeah, well, so plus c, x is 7 plus c. So minus 0.8 times 7. So c, this is minus 5.6 plus c. So c equals to 5.6. Okay, because c is equal to 5.6, that means this point here is 5.6. Okay, so that distance is 5.6, this distance is 7. So therefore we get the area of the triangle is half base, which is 7 times 5.6, which is height. This times 7 divided by 2 is 19.6 units squared. So therefore the B area is going to be 19.6 minus 13. Right? 13. This is 6.6 units squared. So B is 6.6 units squared. Okay. Let's check this stuff. So we got 13 and 6.6. Oh, go to the max screen. First one is right, 13. The next one is 33 over 5. What's 33 over 5? Is that 6.6? It is. Okay. And then that one's right as well. Okay, we got both of those right. And now finally, I think we're on the last question. Holy shit. Okay, so tick. And I'm getting 100% here. There's no doubt in my mind. I'm on 100% and I'm finishing with 100% because I spent too goddamn long here not to get 100%. Okay, so functions f and g are defined by this, where c and k are positive constants. It is given this, the inverse of that. Show that g of f is God. Okay. Well, I remember, so it's g of f of x. This means g of f is a composite function. So g of f. So this just means g of f of x, which is g of f of x, which is g of 4x squared minus c, which is going to be 2 times, you substitute this into x, so 4x squared minus c plus k. Okay, show this, I'm showing this. Okay, so at the moment we have g of f of x equals to 8x squared minus 2c plus k. So we need to find c, right? Not quite there. C will probably be related to k. So if we have this here, so if g of x equals to 2x plus k, then to find the inverse, we simply do that process, minus k over 2 equals x. So therefore, g inverse of x is equal to x minus k over 2. Where's my music at? Where's my music? Okay. Okay, so that means that c equals this. So therefore, so we found, I'm doing this so I can find this. So so g negative 1 of 3k plus 1, 3k plus 1 is equal to 3k plus 1 plus minus k over 2, which equals 2k plus 1 over 2. And this thing equals c. And so, why have I done that? I've done that so that I can get this. So then, now, I'm going to substitute this into there. So g of f of x equals to 8x squared minus 2 times 2k plus 1 over 2, substituting the c into this, plus k, which gives us 8x squared minus 2, so minus 2k minus 1 plus k. This equals 8x squared minus k minus 1. Is that what they wanted? Yes, so that's what they wanted. Okay, so we did that. So that's the answer. E of f of x. Okay, B. The curve we had before, the equation, okay. Following transformations. Find the expression of x of h of x. Okay, so we need to just follow some transformations. Okay, so the first one, second one, third one. Okay, the first transformation was shifting it plus 2 in the x direction and plus 3 in the y direction. So if you want to do, I remember because like x, like if you have y, because this is a parabola, so y equals x squared. If you want to shift that plus 2 in the x direction, like if you think about it, if this is y equals, if plus 2, well, this is going to be x minus 2 squared, because then the new root is here at 2. So this thing, if you want to shift it, so plus 2 in the x axis, this thing will give y equals 8 of x minus 2 squared minus k minus 1, right? And then plus 3 in the y-axis, well, we're just plussing 3 to every y value. So this is going to be y equals 8x minus 2 squared minus k minus 1 plus 3, which will give minus 1 plus 3 is just plus 2, right? Okay, and 2, stretching the y direction by a factor, scale factor k. Okay, we're just stretching it, so we're timesing our y. So this is going to be 8k x minus 2 squared minus k minus plus 2. We're timesing everything by k. So it'd be 8, so we're timesing the whole thing by k. So this is going to be 8k x minus 2 squared minus k squared plus 2k. And the final one is what? Reflecting the x-axis. If you're reflecting the x-axis, all these y values are going to negative. And if they're negative, they're going to positive. Like if it's here, it's going to go here. So you're just timesing by -1, all of our y. So this is going to equal to minus 8k of x minus 2 squared plus k squared minus 2k. Right? Yeah, okay. So that's our final h of x. So we could write h of x equals minus 8k x minus 2 squared plus k squared minus 2k. Okay, that's our final one. Okay, is this the last question? Oh my god, it's the last question. Holy crap. The range of h is given by this. Find the values of c and k. Okay, this is a completed square function. If it's a completed square function, like it's of that form, look it up again, just to make sure you know what I mean. Completed square. Okay. So it's of this form, it's of the form a of x plus h squared plus k, where this is our k in this expression. This is our k, this is our h, and this is our a. And I remember, and it says here as well, that the vertex is going to be, whereas the vertex is going to be minus hk, vertex point. So this vertex point, so vertex, I'll just tell you why I'm doing this in a minute. Just the point hk. So the vertex point this is minus. So the vertex point, which is that point here on the parabola, this point is going to be hk in this form here. And in fact, because it's negative, this will be the highest point. Because this is a negative, a is negative, the graph is actually going to look something like this. This is something like this. And this is going to be IHK. Anyway, the reason for doing that is that if this thing here, so our h of x, which equals minus 8k x minus 2 squared plus k squared minus 2k, if this thing is less than or equal to 15, that means that the vertex point, so our y, which is this k value here, okay, that this thing here is going to be less than or equal to 15. Right, this thing here, because this is our point on this graph is just going to be 2 comma k squared minus 2k, and it's saying here that the range is, this is 15 here, this is the 15 point, so this thing can equal, so it equals 15, so this k squared minus 2k equals 15, right? And then, so you just say k squared minus 2k plus minus 15 equals 0, sorry. And then, so you get k minus 3 plus, no, minus 5 plus 3. So minus 5 and k minus plus 3. Right, you times this together, so minus, yes. So our k equals 5, or our k equals negative 3. Right? Yes. Is there any restrictions on k? C and k are positive constants. Okay, so this can't be it, because k has to be a positive constant. So k is equal to 5, and so therefore c, because we have an equation for c, 2k plus 1 over 2. So c is equal to 2 times 5 plus 1 over 2, which is 10 plus 1, so it's 11 over 2. So your c is 11 over 2. Holy crap. Okay, let's just check that answer quick. How do I do it? Okay, max screen. Okay, let's check these answers. We got, what is this, 11? Okay, 11A. Okay, we did it right, obviously, because we proved it. 11B. Minus 8k, x minus 2 minus k plus, okay, I got that right. Yeah, because I just times in the k. Yeah, so that's the same thing. Okay, and the final answer is k is 5 and k is 11. Okay, boom. Boom. Oh my god. Okay, that was a lot longer than I expected, but okay, we got all those right. And you know what? Even though I struggled a bit because I was trying to explain everything, I'm gonna call that one 100%. So, Jacob, I haven't done this in ages. How many marks is there? 75. Dude, 75 out of 75. Get wrecked, pure 1. I'll get better at this as I do more. But anyway, that is it. I'm coming back. I'm making content. This is really the first time I've actually sat down and made a video in a long time. I have plans to do much larger things than this kind of stuff, but this really gets the ball rolling and starts me putting out content. So thank you for watching. Remember, I have everything already covered. I spent years and years developing courses to make you be able to do this. I haven't even touched this stuff in years, and I just got 100% on this paper. Yeah, I struggled a little bit, but I haven't even looked at it. I haven't even prepared anything here. And so that's how powerful these exam hack courses are, and I'm the one who made them, so I'm a big advocate for them. I have all of the A2 level content, like if you're doing your full A levels, this all on my Patreon, and I spent even longer on there doing stuff, and I'm going to
start to upload more on there, more on YouTube, more on everything. I have a lot. I'm dedicating a lot more energy and time into this platform and into pushing it forward. Anyway, I hope you're all well. I hope your question in existence. I hope this is miraculous to you. I hope you love yourself, and I hope things are going well for you. I love all of you, even though I don't know you, because I love everyone so much. I mean, we're all here, we're all existing. This is insane. This is incredible. But I will see you when I next see you. Bye bye.